So in the last part of this chapter, I'm going to just mention a few things about the physical properties of these ionic compounds, and then I'm going to talk a little bit about naming the compounds if they have a different type of anion called a polyatomic. Okay, so physical properties of ionic compounds, they are crystalline solids. So think about salt, think about table salt, and if you look at a big pile of it, it's a crystalline solid. You look at it, it's kind of shiny on the sides, so it is a crystal. They have very high melting points and boiling points. So if you take some and try to heat it up and melt it, it's going to take a lot of heat to melt that salt. The boiling points also, one of the reasons we add salt to water is it increases the boiling point of the water once you add salt to it. When you dissolve salts in water or crystalline ionic compounds, they separate into their ions. So in water is where they actually separate. So you start out with a solid, like your salt, your sodium chloride. You add it to water, and then you form your ions. So you don't really have the ions until you dissolve those salts in the water. And so what this does is it increases the conductivity of the solution, that is the ability to carry current through that liquid. A polyatomic ion is a cation or an anion that has more than one atom. And they're interesting in that the polyatomic itself is actually covalently bound, all right, but it forms an ionic ion, okay, that is then going to form ionic compounds. So let me describe that just a little bit. When you see CO3 2 minus, okay, what CO3 2 minus really is a carbon attached to 3 oxygens. And those bonds that you see right there, those single bonds, are actually covalent bonds. All right, and this whole thing has a -2 charge. All right, and so this whole thing stays together and moves as an ion. Okay, does that make sense? So when we name that whole thing, CO3, is called a carbonate. NO3 is called a nitrate. OH is hydroxide. PO4, 3 minus, is a phosphate, and then you have a sulfate. Okay, and I've highlighted those because those are your common ones that you're going to see us using quite a bit. And so when you put these with a metal to form an ionic compound, and that's how you know it's an ionic compound, because it's with a metal. If you add sodium to nitrite, that's just, you look up the name of it, and you're going to have a list with the names of these polyatomics, so you don't have to memorize those. So you have sodium plus NO2 minus. You have the charge on the polyatomic, and you use that to go with the charge of your metal to come up with your formula to get your overall 0 charge. You have a -1 on your nitrite, a +1 on your sodium, so they go together 1 to 1, so NaNO2. Barium sulfate, you have a +2 barium, you have an SO4 2 minus, and so those also go on a 1 to 1 ratio. And remember, if you use the swap and drop, you had a barium 2 plus and an SO4 2 minus. If you swapped and dropped, you'd have Ba2, SO4, and you'd have 2 of those. But since the 2's will cancel, you end up with BaSO4. So those that are 1 to 1 are pretty easy to do, right? When you have them where you have unequal charges, like your magnesium, which is a +2 because it's from group 2A, and you have a hydroxide, which is a -1 because I told you that on the chart, then you're going to have to do a swap and drop. And so you've got your Mg2 plus and your OH -1. The -1 goes here. We don't write the 1, it's understood. And then the 2 goes there. Now, When you're writing these polyatomics, remember that they all stay together. So what I have to do is I have to write that as MgOH2. Now, I have to put the OH in parentheses because I'm actually saying I need 2 of that whole thing. So I put it in parentheses because then that tells me I've got an Mg with a 2 plus and 2 OH minuses. If I don't put that parentheses there and I wrote it like this, that would just be saying I had 2 H's, 1 O, and 1 Mg, right? Instead of 2 oxygens, 2 hydrogens, and 1 magnesium. So that's why we have to write those parentheses when we're doing multiples of those. You follow the same exact rules for naming as you did in just the regular ionic compounds. You name the cation exactly the same. You don't specify charges unless you have a variable charge on your metal. And you just write the name of the ion. And remember, I give you those in a chart, so you're already going to know that. So all you're doing is writing that down. So you have sodium, everything, there'll be one metal, okay, one metal. Everything past that metal is the anion. Okay, so you name the metal, and then all the letters past that are going to be on that chart as a polyatomic ion. So this one is sodium, and then HCO3 is bicarbonate. Aluminum sulfate. You don't have to tell me how many sulfates because they can only go together one way because of their charges. Okay, so don't do that because that's where a lot of people will mess up. All right, so remember, I'm going to give you the chart. You're going to see that chart, the polyatomic, or you're going to be able to print that out for yourself. It tells you how to name it, and so then you just have to worry about what your metal is. Okay, so if we say magnesium, let's say magnesium dihydrogen phosphate. Looks scary, doesn't it? It's not. Takes a long time to write it though. Magnesium dihydrogen phosphate. All right, so I've got magnesium. I know what it is, and it's a +2. And I'm going to go over here, and I'm going to find dihydrogen phosphate, which is right here. And so here's the formula. H2PO4, and it has a -1 charge. Okay, so when I swap and drop, or if I use the multiplication like we showed earlier, there's going to be 1 magnesium and there's going to be 2 of those dihydrogen phosphates. So when I write that, I'm going to have to say Mg1, which I don't write, and then and then H, it thinks I want it to get big, doesn't it? Stop it. Stop it. Okay, MgH2PO4. All right, and that I'm going to have 2 of those. So when I have 2 of them, I'm going to put them in parentheses. So I'll make sure that you know that I wanted 2 of those. Okay, if I want sodium hydroxide, I'm going to have sodium, which is a +1, hydroxide, which is a -1. And so that's the formula, NaOH. So I don't have to put them in parentheses unless there's more than one of them. If I did magnesium hydroxide, which is a +2, then I'd have to have 2 of the hydroxides and 1 magnesium, so that would be MgOH2. All right, just remember you keep all of those polyatomics together when you're doing them.